Hello everybody, welcome back to the Insightful Thinkers podcast. The implications of the rapid developments in artificial intelligence have been widely discussed in recent years, but will AI ever take over the world? Some seem to think so, but does the talk about it and all the hype match the actual output in the field? I myself have been skeptical of extraordinary claims of the AI takeover, so I sought to do this episode to learn about AI and where we are really at, and maybe to see if I should be a little more concerned, possibly. The sources of this episode, primary sources, were Artificial Intelligence by Copeland from Britannica and Artificial Intelligence by Bringsjord and Govindarajulu from Stanford. Artificial intelligence is the ability of a computer or a robot to perform tasks commonly associated with intelligent beings. The abilities of intelligent beings are the ability to think, learn, reason, plan, and so on. So this is artificial intelligence, and different forms of AI encapsulate different forms of intelligence. But we've yet to find an artificial intelligence system, or create one, I should say, that encapsulates all of these and matches human intellect. And that's what we see with narrow AI. Narrow AI it's all around us, and these are the systems that carry out specific tasks. So for instance, Siri, vision recognition systems on self-driving cars, or the recommendation engines that suggest products based on what you searched in the past. So if you find yourself Googling something a lot, and all of a sudden you see an ad for it appear on whether it's YouTube or Instagram or some other app, and there's this tracking. This is done by artificial intelligence. So these systems, though, they can only learn or be taught specific tasks, and that's why they're called narrow AI. Some other applications for narrow AI that we may not know and that are just emerging are carrying out visual inspections of infrastructure, so on oil pipelines. Narrow AI can organize calendars, it can respond to simple customer service queries, it can coordinate with other intelligent systems to carry out tasks like booking hotels, it can also help radiologists to spot potential tumors in x-rays, it can flag inappropriate content, and so on and so forth. So narrow AI is all around us already today, but what people seem to talk about more is general AI, and the type of AI that could possibly take over the world, as some people say. So general AI is the flexible form of intelligence capable of learning how to carry out vastly different tasks, like haircutting, building spreadsheets, or reasoning about a wide variety of topics. You talk to Siri, she doesn't reason about all sorts of topics. She may seem like she does, but really she's just spitting out an answer that she's programmed to do in this narrow AI fashion. General AI would be able to respond to every query, and you know how sometimes Siri sends you to the web, or she doesn't know an answer to certain things. This is because she has a narrow-minded AI, but general AI is the sort of AI more commonly seen in movies. If you've ever seen 2001: A Space Odyssey with HAL, how he can basically talk just like he's another human, or The Terminator, or Ava and Ex Machina, where it's almost indistinguishable from a human. This doesn't exist today, and the debates you hear, as I've mentioned, are the debates about whether this type of AI will ever exist in the future. Here we are now in this era of narrow AI without general AI. But where did AI begin? Well, the earliest substantial work in the field of artificial intelligence was done in the mid-20th century by the British computer pioneer Alan Turing. He was a true visionary about computers. He had something called a stored program concept. This is his concept that he created in 1935. He described an abstract computing machine consisting of a limitless memory and a scanner that moves back and forth through the memory symbol by symbol, reading what it finds and writing further symbols. The actions of the scanner are dictated by a program of instructions that is also stored in the memory in the form of symbols. All of this to say that what he basically was thinking of was a computer, and all modern computers are essentially Turing machines. So he was a real visionary because he was thinking about these things and he had ideas about these things before it was even possible to create them. This is why he's the first to really talk about AI and put out the most substantial work in this field. And this was happening in the early to mid 20th century. In 1947, a little later on, Turing gave quite possibly the earliest public lecture that ever mentioned computer intelligence. He says this. He says, "What we want is a machine that can learn from experience, and that the possibility of letting the machine alter its own instructions provides the mechanism for this." So he was really having ideas about computers before, or modern computers before they ever really even existed. One of Turing's original ideas was to train a network of artificial neurons to perform specific tasks. And guess what? Now we have artificial neural networks that are only in their infancy today. But he already had ideas about this way back in 1947. He also created something called the Turing test. This is the test of a machine's ability to exhibit intelligent behavior that is indistinguishable from that of a human. We've talked about the Turing test and some of these ideas about artificial intelligence in the Ex Machina episode, Blurred Lines Between Humans and Artificial Intelligence. So go check that one out if you're interested in these types of things. But we'll go over the Turing test again for anyone who hasn't listened to that episode yet, or if you have, hopefully this is just a refresher. The premise of the Turing test is there's one interrogator, and he is typing to both a machine and a real human. If the interrogator cannot reliably distinguish the machine from the human, then the machine is said to have passed the test. So he's asking both people, or one of them is a machine, or so he thinks they're people. Are you human? Prove it, and this and that. And if the machine can get through that test, then it's said to have passed the Turing test, and it's said to exhibit intelligent behavior, and it's proved that it is intelligent. No AI program has ever come close to passing the Turing test yet. Some authors, they offer the Turing test as a definition of machine intelligence, as Turing kind of did, but even Turing himself actually pointed out that an intelligent computer may still fail the test. So even though Turing is kind of, almost he said that he proposed the Turing test in almost like a joking way, and even though he said that if it passes the Turing test, it is intelligent, he still said himself that an intelligent computer may still fail the test. For example, why should an intelligent robot designed simply to oversee the mining of the moon be able to have a conversation with a human being? If an intelligent entity can fail the test, then the test may not actually function as a definition of machine intelligence. So what if we created a super advanced robot that can mine the surface of the moon and do all these other things, but it can't converse with a human? Maybe it's still intelligent, but it just can't converse with a human. So this is how an intelligent computer could still fail the Turing test in theory. It's even questionable whether passing the test would even be concrete evidence that a computer is intelligent anyway. So in 1956, Shannon and McCarthy argued that it is possible to design a machine containing a complete set of canned responses to all the questions that an interrogator could possibly ask. Imagine if this machine that isn't really intelligent just stored all sorts of answers to every single possible question a human could ever ask. It could, in theory, pass the Turing test, but it may not actually be intelligent. So this objection by Shannon and McCarthy that they proposed in 56 seems to show that a system with no intelligence at all could even pass the Turing test anyway. So on both sides of the Turing test, it may not be perhaps the best thing to test for machine intelligence, but even still to this day, it's a widely known, well-known measure for testing machine intelligence. And the fact that no machine has ever passed it kind of still is an indicator of how far we have to go in artificial intelligence development. We have a long way to go to getting to that point where a machine could pass the Turing tests. And so where are we now? Let's talk a little bit more about the current state of AI. AI is widely used in healthcare. Well, I shouldn't say widely. It's just beginning to be used in healthcare. Look at IBM's Watson. IBM created a clinical decision to support tool. And this tool was trained by oncologists at Memorial Sloan Kettering Cancer Center. So IBM's Watson clinical decision support tool basically synthesizes information that clinicians can use on the spot to make clinical decisions. So instead of a clinician needing to read all of the papers and do all of the kind of the groundwork, IBM's Watson just synthesizes it all and helps doctors make decisions. So that's an interesting way it's applied today. Google's DeepMind systems at the UK's National Health Service also help spot eye abnormalities and streamline the process of screening patients for head and neck cancers. So it's starting to be used in healthcare. On the other end, perhaps more nefarious side, it's being used in surveillance. In China, authorities are mounting a nationwide program to connect CCTV across the country to facial recognition and to use AI systems to track suspicious behavior. So what China has is a social credit system. This is a set of databases and initiatives that monitor and assess really the trustworthiness of individuals. And so what happens here is they're using facial recognition software. They have cameras littered all around the country, and it creates a rating for the citizens in the country. So a good rating, if you get a good rating based on what you do kind of in the streets, based on your facial recognition, and also information it gathers from criminal records, government records, and other sources like financial records and things. If you have a good record based on all these things combined, then you could get priority health care. You could get deposit-free renting. But with a negative rating, you could be banned from flights and from trains, and you could face all these other consequences. So it's using video surveillance as a data collection method to build credit ratings for its citizens. So who knows how far they could take this? Are they spying on the people? What are they doing? Nobody really knows. They say it's just to be added to the social credit system, which is already weird enough in itself, but who knows what other means they could be using the video surveillance for. AI is also being used in driverless cars. Waymo, the self-driving section of Alphabet, which is essentially Google, it's Google's parent company, is already offering self-driving taxi rides. Just a few months ago, I think it did its first drive. It's been driving passengers around Phoenix and with its driverless Waymo one ride service. So there are videos on YouTube of people using this service of a driverless car, just like a driverless Uber or a driverless taxi that takes you wherever you want to go. No driver there, no nothing, and it's just steering itself. This already exists today. These applications, they're interesting, they're compelling, but there's always a but, you guys, with AI, is what I've been finding. It's not all going to be an easy development to getting the HALs of 2001 Space Odyssey or getting the Avas from Ex Machina. At the present time, even an embodied system displaying the overall intelligence of a cockroach is proving elusive, let alone a system that can rival a human being. There are currently no programs that can match human flexibility over wide domains or in tasks requiring even basic everyday knowledge. And exaggerated claims of success in professional journals, as well as in the popular press, have damaged their reputation. So the more hype you hear about the AI and how intelligent it is, or Sophia is one where you hear so much about how she's able to converse with people and things like that. The more you hear, the more actually damaging it is to the reputation of these very advanced AI robots, because it really only highlights how far we have left to go. And when you really examine how far we are, you realize that we're not very far at all in AI development. Connectionists who work on creating artificial neural networks that Turing thought about in the mid-20th century are unable to model the nervous system of even the simplest invertebrates, let alone humans. We thought we would be able to create an artificial brain just like in Ex Machina, you see he's created artificial brains with silicone. We're not even close to being able to do that, you guys. Critics don't believe that high-level behaviors involving language, understanding, planning, and reasoning could somehow emerge from the interaction of basic behaviors such as obstacle avoidance, gaze control, and object manipulation. So critics say that even if you combine all the advancements we've made with, okay, there's a self-driving car there, there's a clinical decision support tool over there, and there's Siri over there, and there's Sophia, and let's combine all of these programs, and could we create something similar to a human or more advanced than a human? Critics don't think so. There's a lot that goes into combining all of these features, and yeah, an artificial intelligence system can model a basic behavior very well, but what happens if you extend past that basic behavior? Is it going to be able to do that too? And is it going to be able to help you make a clinical decision and then all of a sudden have a full conversation with you? Probably not, the critics say. Nobody has ever developed a chat bot that is able to speak with you, even that can hold an hour's conversation without sounding bizarre, or a robot that can perform tasks even at a preschool-like level that requires any type of flexibility and adaptability. So really, you guys, what I've learned from what I've been reading about AI is that we are very far off from robots ever taking over the world, and things like that, and the extraordinary claims that you hear today. But we're not too far off from AI taking over jobs, it doesn't seem. While AI won't replace all jobs, what seems certain is that AI will change the nature of work, at least. The only question is how rapidly and how profoundly automation can alter the workplace. Look at AI expert Andrew Ng. He says, many people are doing routine, repetitive jobs. Unfortunately, technology is especially good at automating routine, repetitive work. He sees a significant risk of technological employment over the next few decades. But which jobs will be taken over? You hear this talk a little bit from the Democratic political candidate Andrew Yang. He actually talked about this, and a lot of his campaign was built on not fear-mongering about AI taking over jobs, but he does seem to be more conscious about this. Which jobs will be taken over? Well, Amazon really is the leader in creating AI that will take humans' jobs, it seems. Amazon, to be fair, also does create a lot of jobs for humans, but it seems to take quite a few away with the AI it's developing. It's recently launched Amazon Go. You've probably heard of the store in Seattle where a Prime customer can just walk into the store and grab whatever he or she wants and walk right out without paying, without a cashier needing to be there because of the facial recognition or video recognition technology that knows what the consumer took and put in his or her bag and things like this. So it's important to know that 3 million people in the US currently work as cashiers. What if the whole United States becomes something like Amazon Go where no cashiers are needed? Well, there goes 3 million jobs. But then again, let's look at the other side of this, you guys. If we're going to be creating all of these Amazon Go stores, who's going to create them? Is that going to be only AIs? No, a lot of humans are going to be creating these stores too. So it's going to create a lot of jobs as well. But over time, it's not going to level out. It may create a lot of jobs in building the store, but after that, there are going to be no jobs for humans. What's going to happen there? Amazon is also using robots to carry products to human pickers who select items to be sent out. You've probably seen videos of that too with the little ground robots. They look kind of like like those automatic robot vacuums, like little circles, but they can carry huge pallets. And then the only thing that people are needed for is to determine which items are going to be sent out. Amazon has over 100,000 bots in its fulfillment centers, and it plans to add many more. So we're starting to see this interfere with jobs, and who knows where this will lead us. Let's conclude today with some of the philosophical ideas about AI and the future of AI. And let's talk about some distinct opinions about where AI is headed. AI's future has really been hyped since its inception. Overly enthusiastic predictions from AI professionals have excited and sometimes terrified journalists and cultural commentators. Today, the prime example of these predictions is the singularity. The singularity is this proposed point in time when machines will become more intelligent than humans. Kurzweil, in his book, he proposes this in his book, The Singularity is Near. You also see books that propose similar ideas, like Bostrom's Superintelligence. In the case of AI, though, it seems that progress towards this singularity may be slower than what most expect. After all, look at what was happening in the 1950s and the predictions that were going on in Turing's time. At the 1956 kickoff conference discussing AI, Herb Simon predicted that thinking machines able to match the human mind were just around the corner. There was a lot of excitement about AI early on, and as it turned out, though, the new century arrived without a single machine being able to converse at even the toddler level. So for all the hype, for all the predictions, for all these just around the corner ideas, don't get me wrong, we've made some great developments, but we don't seem to be close to these robots that with the red eyes and the nefarious minds and malevolent ideas that they have about taking over the world. We're far from that, you guys, is what it seems. Let's talk about the Nick Bostrom versus John Searle argument as an illustration of the differing views on the future of AI. These are both experts on AI, both philosophers. So on one hand, we have Nick Bostrom, who wrote Superintelligence and paints a dark picture of a possible future of AI, whereas Searle says we don't need to worry about this because AI, it's never going to be conscious anyway, and it needs to be conscious to be malevolent. So how could it even be malevolent? Let's talk about this discussion here. Nick Bostrom points out that the first superintelligence could have the capability to shape the future of Earth and could easily have final goals counter to those of humans and would likely have reasons to pursue resource acquisition. He says this in his book. If we now reflect that human beings consist of useful resources, such as conveniently located atoms, and that we depend on many more local resources, we can see that the outcome could easily be one in which humanity quickly becomes extinct. So he's thinking that, we have resources, inherently we are a resource, and if an AI could look to use us as a resource for their survival. Other AI experts believe such projections, though, are wildly optimistic and believe that AI with such intelligence is centuries away still. This is what John Searle thinks. He's an American philosopher, and he thinks Bostrom's book is very misguided and fundamentally mistaken, and that we have no need to worry about the nefariousness of AI. Listen to what he says. He says, machines aren't conscious. Bostrom is alarmed at the prospect of malicious machines who do us in. But a malicious machine is a conscious machine. Therefore, Bostrom's argument doesn't work. He writes this. If we are worried about a maliciously motivated superintelligence destroying us, then it is important that the malicious motivation should be real. Without consciousness, there is no possibility of this being real. So Searle is thinking that Bostrom is almost jumping to the conclusion of machines, they're going to be malicious towards us. But Searle says, wait a minute, for them to even be malicious towards us and have the ideas to do this, they have to be conscious in the first place. And we don't even understand our own consciousness as it is. How can they attain consciousness before we even have an understanding of consciousness to be able to create it inside of them? And then after they get this consciousness, then they still have to take the next step of becoming malicious towards us and to have motivation. To have motivation, Searle says, is an inherent trait of consciousness that machines do not have. So these are the differing opinions, you guys. Totally opposite ends of the spectrum. On one hand, you have, oh my gosh, AI is going to advance so rapidly. In 2050, we got to watch out. And then on the other hand, it says, we'll never have to watch out, or at least not for a very, very long time. In Searle's case, he says centuries, because AI is not going to be conscious anytime soon, and it has to be conscious before it can be malicious. Searle's critique of AI, let's close with this, you guys, and AI's possible consciousness is best exemplified in his Chinese room thought experiment. This was first published by him in 1980. So we've again talked about this in Ex Machina, blurred lines between humans and artificial intelligence. Imagine someone inside a room is reading Chinese symbols that are sent into a room, and he sends back answers using a rule book for translating Chinese. So imagine let's imagine me and you. So you're the one sitting inside of the room, and your only job is to translate Chinese symbols to English. So I send a sentence in Chinese, let's say, I put it inside the box, you take it, you don't understand Chinese at all, but there's a image of, okay, this symbol means this word or this sentence, and this string of symbols means this. So eventually you'll be able to decipher that and send me back an answer in Chinese using reverse coding. And then you look at your sentence you want to create in English back to me, and then you just look at the corresponding Chinese symbol and then write it all in Chinese and then send that back through the box to me. And then I read it and it looks like great Chinese. So even though the person inside the room successfully spits back answers, they have absolutely no idea what the Chinese symbols mean on their own. Imagine if the person inside the room serving as the translator was a computer. This is what Searle is getting at. Just because the computer can translate language so amazingly and so brilliant in conversation using an algorithm, it doesn't mean it actually understands the language. To Searle, this means that no computer could harbor a true understanding of language or anything else for that matter that requires a true understanding. So, if a computer can never gain a true understanding and experience what it is to really understand something, how could it ever even be aware enough to turn on humans in the future then? Searle asks. But what I will say, and what many say, is maybe we'll never know. And if we let AI development get out of control, then it may happen sooner rather than later, when these machines that we don't even think could ever be conscious could turn on us. Thank you for listening to this episode, everybody. We are growing our community through word of mouth, as you guys know. So if you liked this episode, please share it with one or two people who are also interested in artificial intelligence topics. Please subscribe or follow and leave a star rating or a review on Apple Podcasts or a like on YouTube. And share your ideas through the YouTube comments section, the Connect page on the website, or through social media. Check out the blog posts on the website. And if you want to join our monthly ITP video conference call where we analyze topics together every month, you can support the podcast on Patreon. But whatever you guys do to support listening and watching is always plenty, as I say every time. Thank you so much for listening to this episode, everybody. We'll be back next Monday, as always, for more in-depth analysis into a diverse set of topics. Take care, everybody.